Hari. Now, in this part, we are considering a problematic situation where we assume an object of mass m projected up with a velocity which is greater than the escape velocity from the earth. Suppose that I am projecting this mass m with 2 times the escape velocity. Then the particle will be moving up and up and up. It reaches here and it crosses the gravitational boundary and it continues to move. Now what is the velocity v with which it crosses the boundary? It's not stopping there because it is having enough velocity to move further. So what is the velocity v when it just crosses over the boundary of the gravitational attraction? So to understand that, we will be considering again the law of conservation of energy. So total energy of the particle when it just starts from the earth is equal to minus g me into m divided by re, that is the gravitational potential energy of the mass m on the ground, plus half into m into 2 times v escape the square. That's the kinetic energy with which it is starting from there. So this is the total energy when the body just starts from here. And as the body just crosses over the boundary, you can see that the gravitational potential energy at that point will be g into me into m divided by infinity. You got the reason for it. Plus half into m into v square. This v is the velocity with which it just crosses the boundary. Now our aim is to find how much is this v. Now from this it's very clear that half into m into 2 times v escape the square minus gme into m divided by re will be equal to, this will be 0, half m v square. But from the derivation of escape velocity, we understood that the value of this will be equal to, that is gme by re, that will be equal to half m into v escape square. This is what you got from the previous derivation for escape velocity. Then this will be half into m into 2 times v escape the square minus, this will be equal to half m into v escape square will be equal to half m v square. And from here you get 4 times v escape square minus v escape square will be equal to v square. Half m is common factor that goes through. And therefore, you can find that 3 v escape square equal to v square. Therefore, v will be equal to root 3 times v escape. This is a very important research. Now, this is the derivation and we got the value of v when it reaches here. The value of v is found to be greater than v escape. So this is something against our concept. Like we know that that if we project the particle with B escape from here, it just manages to reach over here. By then its speed will be 0. So naturally, if I give 2 times B escape, what we think is that half of it, that is B escape is required to reach over here, then the remaining B escape it goes. But in the real case, the value of B at that point is found to be greater than B escape. Now you find the answer for that one. Think of that one. Why it comes like that? Okay? Why it comes like that is a path to be total. Alright? So, method, remember this, and apply the conservation of energy wherever it is necessary. Okay?